Good day, everyone. I welcome you all to the video lecture on how to work on Keil Microvision 4 MDK. Basically, it's a tool through which we will program several microcontrollers. It's a very useful tool. So in this video lecture, I'm going to teach you some of the fundamentals of how to work in Keil. Okay, this Keil software is particularly available in Keil's website itself for free. The student edition is for free. It has all the features of a professional edition. The only limitation you will have is the size of code you can compile in this tool, and the size that they have allocated in the student edition is far more sufficient as far as this particular course is concerned. So this Keil MDK is basically an Eclipse platform based tool. So when I say Eclipse, there are various software that are based on Eclipse platform. When I say that, what I'm trying to tell you is most of the buttons or the menu or the shortcuts available will be very similar to the other software that you would have seen earlier. Okay, like in PSpice or VC++ or Visual Basic, etc. Okay, so you can go to Keil's website. What you have to download is there are several versions of Keil MDK available. For you specifically, it will be either Keil MDK version 4 or 4.4, or if you're getting confused with the MDK versions, there is a separate version of Keil available only for 8051. You can download that too. Okay. So now let us go into what are the different menus available in the tool, how to navigate, how to create project, how to create a file, add a file to the project, how to compile it, in case there is any error, how to correct it, how to debug, get into the debug session so that we can run the program and see the result. Okay. First, as you all know, you have different menus here: file menu, edit menu, view, project, flash, debug, peripherals, tools, etc. Some of the important menus that we are interested in: file, then project, debug, peripherals. These are the menus that we are interested in as far as the initial few classes are concerned. So file, if you go to the file menu, you can either open a new file or open an existing file, save a file, or you can even exit. So these are very limited options available as far as the file menu is concerned. The most important menu of all would be your project menu, where under the project menu you can create a new Microvision project, or you can open an already created Microvision project. Apart from that, though the options are not highlighted here, once you create a project and add a target device to it, there will be several options available for you to configure the target device or the hardware or the microcontroller. Now, the debug menu is another important menu. Only you can run a program only when you're inside the debug menu. So once your program is compiled successfully with no errors, you get into the debug menu. That is, you start the debug session and then you go on to run your program, stop your program, step in, etc. Peripherals, nothing is shown here because we haven't configured any hardware. Based on the hardware that you have configured, whatever peripherals are available or associated with the hardware will be present here in the peripherals menu for you to view. Okay, so first let us see how to create a project in Microvision 4. You go to project menu and you go and click new Microvision project. Okay, one piece of advice that I will give you while creating a new project is please create a separate folder for every project that you are planning to create using Microvision or Keil. The reason being, every project that you create will generate, when you compile and generate your executable, will generate a lot of other new files associated with the project. Okay, so if you don't create it in a separate folder, is there anything wrong? No, there is nothing wrong. The only problem is all the project files, say you're planning to create 4 or 5 projects for your lab sessions, one for each lab session, all the files will get mixed up. And whenever you want to access a particular file of a particular project, you may get confused of where it is, or it will be very difficult for you to locate. So for the ease of access, for every project you are going to create in Microvision 4 or Keil MDK 4, please create a new folder. So I'm creating a new folder here. I'm going to call it demo project. So I've created a folder called demo project. I'm going to create my project inside this folder. Let me call it as mic proj 1, microcontroller project 1, some name for the project. Please make sure you do not give any keywords. Okay. I've created a very simple project with the name mic proj 1. So I have saved the project. Once you save the project, what you see here is the tool or the software will ask you what kind of processor database you want your target hardware to be chosen from. Okay, what kind of microcontroller you want to choose, okay, based on the database what you select. So there are several options available. You have NU Micro Cortex M0 database, NU Voice database, but we are more interested in generic CPU database as far as this particular course is concerned. So I'm going to choose generic CPU database and click OK. The moment I click OK, dialog box opens up in front of you, and you see lot of names here: Acer Labs, Actel, Aeroflex, Altium, Analog Devices, Anchor Chips, ARM, ASICS, Atmel Wireless, Austria, and so on and so forth. You see how many names you see here? All these names are nothing but several vendors who manufacture different kind of microcontrollers. Okay, for example, Microelectronics manufacture STM32 boards like STM32. Okay, Samsung has their own processors, Philips has their own processors. Okay, ARM has their own processors, and Atmel has their own processors. So all these names, what you see here in this menu, are nothing but vendors who develop different microcontrollers. For this particular course, where we are going to focus more on 8051, we are interested only in Atmel. Okay, though 8051 was initially founded by Intel, later on several manufacturers started developing microcontrollers similar to 8051, and Atmel is the most known for. So we are going to go for Atmel vendor for this 8051. So you have to drop down this menu by clicking this symbol. Once you drop down, you see several versions of microcontrollers that are manufactured by Atmel. Okay, so whenever you choose a particular processor, on the description side, you also get to know about the processor's clock speed, how many input output lines are there, how many interrupts are there, how many watchdog timers are there, how many timers are there, what is the RAM, on chip RAM size, everything, all the description, the complete description about the processor is being projected here for you. Okay, so now what is that particular processor that we are interested in? We can go for AT89C51, which is a generic 8051, but I'm not going to pick that. I'm going to settle with AT89C51 ED2. Why? Because this is a very specific processor or the microcontroller that is present in the lab microcontroller kits that you will be working on. Okay, so now when I teach this software part with that particular chip, it becomes easy for you to choose the same chip while you perform the lab experiments as well. So that is the reason I'm picking it. So once you pick it, you click OK. And once you choose your processor, the next thing the tool will ask for is whether to copy a file called startup.a51 to your project. Now, this is a very important file as far as C programs are concerned. That is, there are two ways you can program 8051 microcontroller using this tool. One is by writing C program, one is by writing assembly program. Okay, when you write assembly program, this startup file is not required. But when you are going to write a C program, this startup file is definitely required. Okay, right now I'm going to demonstrate the working in Keil using an assembly program. So this startup file is not needed. Again, I'm telling you, the startup file is needed only using C programs and not assembly programs. So I'm going to say no. Now when I click no, you see the target is created and there's something called source group. Okay, now as of now there is no file created or any file added to the project. That is why you see the source group empty. Now you have created a project, you have told the tool that this is going to be my target, 89C51 ED2 is my target. Now what is the function that you have to write? the logic that you have to write, you have to write it as a code. So how do you do it? Very simple. What you can do is you can create a new file either by going here and clicking this option, or straight away this particular icon. Do you see the icon getting highlighted? So click that. You will see a new text editor here. So this is the area where you type your code, okay, and add it to the project. Now don't worry about the syntax that I'm going to type now, because we haven't actually covered instruction set and other things for you. This is just a video demo to show you how to work in Keil, how to create projects, how to create source files and add it to the project, compile them and run them. Okay, so I'm writing a code here, a very simple code. Okay, so this is my simple 3-line code. So it has a start beginning, something that I want to do in between, and then an end. Now this file has not yet been saved. So the first thing that we have to do after creating a source file is to save it. So the moment I click save, remember I asked you to create a folder and then save your project in that folder. You see, I created a folder called demo proj, and that is where this thing is there, right? So it automatically will point to that folder. So you have to type a name here, file name. Again, please don't give any keywords here, let it be generic. Okay, so I am typing a program. Now if you note the file type, everything will be highlighted as all files. So it's up to the user to say to say to the tool that whether it is going to be .asm or .c file. Okay, if you do not specify, it will be saved as a generic file and you will not be able to locate it when you want to add your file to the project. So please be careful to specify program name dot extension, that is it's going to be either .asm for assembly or .c for C extension. Since this is going to be an assembly demo, I'm going to save it as .asm and press enter. Now if you see, the moment I saved it as .asm, all the keywords will be highlighted. Okay, the syntax, if it is correct, it will be highlighted. Okay, this indicates that I have created a program to do something. I have saved it as .asm. But if you see here on the left hand pane, I haven't still added the file to the project. I haven't added the file to the project. So how to add the file to the project? There are two ways of doing it. One is highlight source group, right click, go to add existing files to the group. So when I say add existing files to the group, it automatically goes to that particular folder. You are not able to find anything here because the file type says C source file. Okay, since we have created an ASM file, we have to look for that. So choose ASM source file. There you see my program is there. So you just say add and close. Now after adding, you see this becomes expandable and you see your program automatically present here. This is one way of adding. What is that? Source group, right click, add existing file to the group. Okay, so if this is one file, no problem, you can add it this way. There is another way of doing it. How is that? Now I am removing the file. Okay, another way of doing it is, you see a box here. Do you see that getting highlighted? My arrow highlighting the box. This is the token that you need to press. It says target 1, source group 1. Then it gives me an option to add any number of files. So I say add files. Again, it goes to that respective folder. You're not able, if you have created a C file, your program would be listed here, but we have created an ASM. So just go here, go for ASM. You see my program. You say add. This dialog box will not close automatically. You have to close it. So the program has been placed here. Now you say OK. You see my program has been added here. Now that my program is added here, before compiling, I have to specify certain specifications, or I have to put forth certain specifications before the program can be compiled and run. So what is that? You again go to this project tag or project tab or project option. You see here you have something called options for file demo program 1.asm. Click that, simply click OK. Now again go to the project tab. You see now it has changed to options for target. You have to click that. This is a very, very important step. Do not forget. You go to device. We have already chosen 8089C51ED2 as the target, so there is no change in that. Now come to target. Now the default crystal oscillator frequency at which your microcontroller operates is 33 megahertz. You can leave it that way or have any number there. As far as the simulation is concerned, it's not going to be a problem. Okay, but whenever you want to target your executable to a particular hardware or to a particular board, you have to be very sure that the number what you put here and the oscillator frequency what is there on the board are almost the same. If not, there will be a mismatch and the synchronization problem will be there when data is being communicated between the components or between the interfaces. Okay, the clock frequency that is present in the microcontroller kit that you're going to work in the lab is not 33 but 11.0592 megahertz. So I have changed the clock frequency. Rest I'm not changing, I'm leaving it as such. The next tab that you will be working on is the output. Create hex file is very, very important. As far as simulation is concerned, again, whether you create a hex file or not, it doesn't matter. Your simulation will either way run. But when you're going to target it to hardware or program it in a simulation software called Proteus, which is going to mimic the hardware present, it is something like PSpice, where you have the real diodes, resistors, transistors, you pull everything in and connect it and then simulate it, right? So similarly, there is a software called Proteus, which you will be, which you have to download and then run it in your system. There you can pick up 8051 microcontroller, you have stepper motors, you have switches, you have LEDs, you have LDRs, all the necessary sensors, and then you can connect it, come to Keil, run this program, create a hex file, go back to the Proteus, add the hex file to the processor, and when you simulate, it will work as if it is working in hardware. So during the Proteus simulation or real hardware emulation, this creating hex file is very, very important. This is your executable. This is what you will be uploading or downloading to the board. As far as simulation is concerned, it doesn't matter. So since I'm going to give you a simulation demo as of now, I'm not creating a hex file, but this is a very important step if you're doing it in hardware or Proteus simulation. The next tab that you will be working on is debug. So by default, it is in simulation mode. If you want to go to hardware mode, you have to come here and click this. Not only that, you have to choose a particular driver via which you are going to communicate with the board. Generally for 8051 using Keil, we will use Keil Monitor 51 driver. Okay. Now you see two options, whether it is simulation or hardware emulation. You see something called a run to main. Do you see here? This needs to be checked only if you are using a C program. If you are able to, work on ASM, or if you are working on an ASM, this need not be checked. Okay, got it? Like your startup file. Okay, startup file is needed only for C program and not assembly. Similarly, this run to main has to be checked only for C program compilation and not assembly compilation. Now all these options for target has been set. Just click OK. Now we are all ready to compile the program. Okay, when you're doing it for the first time, translate it. When you translate it, see, it gives me error. This is the window where your errors or warnings or whatever is being displayed. Okay, so it gives me one error. What is the error I have made? Of course, you don't know the syntax. So the error I have made is I have missed a comma, a separator here. Okay, so that is why it is showing me as an error. Once I save it, again I see now the error is removed. It says 0 errors. Okay, now after translating, I'll do the linking. Once I do the linking, then I do the build. So this is translate, link, and build. This is translate, link, and build. This is rebuild. So once your program is built successfully with 0 errors and 0 warnings, we can go for running the program. Okay, for running the program, I told you, you have to get into the debug session or start the debug session. You can either do that by going to this debug tab and say click on the start stop debug session, or there is a shortcut key here. Do you see this getting highlighted? You can directly click this. The moment you click, you will get a warning message saying that what you have downloaded is an evaluation mode and not a professional version whose code size limit is 2K. This is no problem. I mean, this is not at all a problem. We are this is well within our limits of whatever we are going to program. Just click OK. Once you click OK, it will go into the debug session. Now in this program, what I have done is I'm requesting the software to move the value 20 hexadecimal number into the register R1. This is what I'm asking the program to do. Move a 20 hexadecimal number. H represents hexadecimal. 20 hexadecimal number into the register R1. Move. So R1 is this register, as you see here. So there are several ways of running this program. This is the reset button in the debug mode. The moment you press, everything, all values will be reset to their initial values. This is the run button, one-time run button. You click this, the program will run once. You will not be able to observe the minute changes that are happening during this program. This is the stop. When the program is running, if you want to stop the program, you just click that. Okay, this is called a step in, which executes the instruction step by step. This is step over. Okay, this program being a small program, and I'm asking the program to move 20 to R1. I'm just going to execute it step by step. So when I click this, you see here R1 has got 0, 0 initially in it. The moment I execute that particular instruction, this particular arrow mark indicate what is the instruction that is going to be currently executed when I click this. Okay, so when I click this, you will see the change that this R1, which has got 0, 0, will change to 20. Do you see that? So that has been executed. Since that's the only executable after which the end is there, no matter how many times I execute, nothing will happen. Okay, so this video demonstration showed you, if you want to come out of debugging mode, just click that button again, it will come out of debugging mode. So in this particular video, we saw how to create a project in Keil, how to choose your target, then how to create a new file and save it as either .asm or .c, then how to add it to your project, how to go and set the project options, and then once you set your project options, how to start the debug session, how to run, where to see if there are any errors or not, and finally run the program either in one single step or step by step, depending upon how you want to see your results where. There are more interesting things about working with Keil. We'll deal it in detail as we go through this series of video lectures one by one. Thank you.